At any rate, you know that you could take that 14 over 3 and change it into what's called a mixed fraction. A mixed fraction would come from dividing the 3 into the 14 and asking how many times does 3 go into 14? Answer is 4, and the remainder is 2. So these terms that you're seeing here are terms I needed to know. The thing that you divided was regarded as the dividend. So that's what this arrow is pointing to right here, right? That's the dividend right there. And then down here we have the divisor. So the 14 is being divided by the 3. And when you divide the dividend by the divisor, you end up with a whole number quotient with a remainder over the divisor. This whole circle that I'm pointing to here is regarded as the quotient form, right? So that's what I want you to remember. It's called quotient form. Quotient form is when you put the quotient with the remainder over the divisor. This is the improper fraction form where you just have the dividend being divided by the divisor. So none of those terms should be terms you're hearing for the first time, right? Now, if I wanted to check the accuracy of my division, if I wanted to know whether the quotient form that I got was right, I could do something called the division statement. The division statement says take the quotient of 3 multiplied by the quotient in this case was the 4. I'm sorry. Take the quotient of 4 multiplied by the 3 and add on the 2, and 4 times 3 is 12 plus 2 is 14. It gives you 14 over 3. So what this down here is telling is that when I take the quotient times the divisor and add the remainder, I do get the dividend. The dividend in this case was 14. And that's why 4 times 3 plus 2 does give you back the 14. Again, stuff I'm expecting you to remember from when you're in elementary school. So that's not grade 12 stuff yet. We're going to get to the grade 12 stuff shortly. But that's not grade 12 stuff yet. So I want you to join me now. The thing that you're going to have to do is I don't know if when I move over to the second board, whether you will automatically do that, but I do need you to come over to the second board at this point. So let me just delete that here. Hold on one second. Hold on. Let's get rid of this thing right here. Okay, here we go. So I'm now on the second board, and oh, something just went wrong. Back up to the top. Here we go. Okay. So again, I just have to sort of get the feedback from the class. Did everybody go over to the second board, and can you see what I have on the second board? Right? Perfect. Okay. So the only disadvantage to this is that you have to navigate to the board yourself. So if you stay on the first board, you're not going to see what I'm seeing. But I don't really know. I mean, I'm assuming that's what you have to do. But I had to navigate to the second board on my own from my second screen. So I'm going to assume you have to do the same thing as well. Right? Okay, so we're now on the second board, and it says express the result of these divisions in quotient form. I mentioned quotient form before. Identify the restrictions on the variable and write the corresponding division statement and verify your answer. We're going to do exactly that right now. To do that, we're going to do something called polynomial division. If you look at the top of the board, you'll see that I have that term right there, polynomial division. So the way this works is as follows. If you remember how you divided back in grade 6 or 7, when it is that you did long division, it's going to look very similar. I'm going to put, I'm not sure I'm using purple, by the way, but anyway, purple is fine. X plus 1, and remember, that's the thing that's the divisor I'm putting on the outside. And then under that, I'm going to put the x squared plus 3x plus 5. Okay, hopefully so far so good. What I'm going to do now is something you need to pay close attention to. I'm going to divide the first term of the dividend, which is the x squared, by the first term of the divisor, which is the x. So what I'm going to put it on the side over here, I'm going to have x squared divided by x, which of course is equal to x. I'm going to put the result of that division over the term that is just simply x. So in this case, that's the 3x. I'm going to put an x right there. Then I'm going to multiply that x on top here by the two terms on the side over here, right? So this x on top here is going to be multiplied. So this x on top here, one disadvantage I'm noticing is I don't think you can see when I'm pointing to something, but I am pointing to the x on the top. And I'm going to multiply that x by the x plus 1 on the side. So it's going to be x times x, which is x squared, x times 1, which is x, so plus x. Put a line under that. So all I've done is I've multiplied the x that I got from the division by the what was the divisor on the outside here, right? So I'm going to do, what do you think I'm going to do now? What do you, based on what you remember from back in grade 6 or 7 or 8 when you did long division, what do you think I'm about to do now? Okay, go ahead, please, Jeremiah. Correct. Now, the first term is always going to cancel out. And the reason for that is because you divided the x squared by the x first and got the x. So when you multiply it back, you're going to get the same term back again. So that's always going to cancel this out right here. The first term is always going to cancel. But I'm going to have 3x minus x, which of course is 2x. Okay? And then I'm going to do what next, you think? Right? Think about what you did back in grade 6 or 7 or 8 or whatever it was that you did this. What do you think the next thing is I'm going to do for the next step? Just guess. Let me take a guess from you. What do you think I'm going to do next? Bring down the 5. Thank you, Noah. So I'm going to put plus 5 here. And then I'm going to do the same thing again. The first term that I have here. Yes, go ahead, please. Jeremiah. Yep. Yeah. You know what? To be honest with you, I don't think it really makes that much of a difference. You'll see at the end that you're going to get a quotient, you're going to get a remainder, and at the end of the day, whether you put it over the 3x, which is what most people do, because it's the same, or it's the same degree. So the 3x is a degree 1, so the x is a degree 1. They usually put them over each other. To be honest, it's really just a matter of window dressing at this point. It's just a matter of style window dressing. I don't make a big deal of that. That's not a big deal for me anyway. Yes, Shania, please go ahead. No problem. Okay. So Noah is right. He said bring down the 5, which I just did. And we're going to do, so maybe this will help you, Janak, because I'm going to go through the same steps again. The first term that I have here is 2x, right? I'm going to divide that 2x, put it on the side over here. I'm going to divide that 2x by the first term of the divisor. So 2x divided by x. That, of course, is going to give me 2. So I'm going to put that 2 here. And again, Jeremiah, I'm going to put that 2 over the constant term because 2 is a constant. I'm going to put that over the constant term. Does it matter? Not really. So what I'm going to do now, Janai, is going to multiply that 2 that I got. So remember, 2x divided by x, of course, is 2, which I think you would agree with. I'm going to multiply that 2 now by both terms in the divisor. So 2 times x, which is 2x, and 2 times 1, which is 1, plus 1. And again, I'm going to subtract. So the 2x and the 2x will cancel. That always happens. The 5 minus the 1 is, of course, 4. So we have a remainder, right? We do have a remainder. So here's what it's going to look like. If you go back to the first page, you'll remember that I put the quotient, and the quotient in this case is this thing at the top up here. That's what the quotient is. That's the quotient. So I'm going to write this in quotient form now. I'm going to put x plus 2. Then I'm going to put, this is quotient form, the remainder, which is 4, and it's a plus 4, by the way, over the divisor, which was the x plus, what was it, x plus 1. This thing here is my quotient form. This is just like taking the original function, which was this thing up here, that's x squared plus 3x plus 5, right? Just like taking that and saying that's an improper fraction, thinking of that as an improper fraction, right? So this thing right here, I'm going to think of this as an improper fraction. Okay, one of the things I'm noticing that's a drawback is that, oh, you know what I could do? Let's see, move and resize pointer. Maybe there's a pointer tool here. Let's see. There probably is a pointer tool. Because what I'm noticing is that when I move my mouse around, you don't see it unless I'm actually writing. which is kind of a bummer. So I wonder if, I'm just trying to think here now. Select, if I press select, put my mouse here. No, that still doesn't show up on your end apparently. Yeah, select doesn't work. Move and resize, does that work? Moving it around there? No, that doesn't seem to work either. All right, that seems to be one limitation of what we're doing right now. It should be 3 and not 4. 5 minus 1 is not 4. No, it's saying, I'm not sure if I followed what you're doing. Okay, let me go back and see. I wasn't looking at the comments yet. Bring down the 5, I did that. It's not 1. Oh, it's 2 times 1, which is 2. Yeah, you're right. 2x plus 2. Yes, 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 you're right. I'm just noticing the comments that people are making. So let me do a little erasing here. That's absolutely wrong. It's 2x plus 2. You're absolutely right about that. So this should be 2, and then this should be a remainder. And you know what? We would have figured that something was wrong when we got to the end because we can use the division statement to check it out. So 2 minus 5 is in fact 3. Okay. So let me just double check that. I'm glad that people are picking up on stuff like that. That's excellent. That's really, really good. Okay. So let me go over that again, right? I should have said I divided the 2x by x and I got 2, right? And what I should have done is said 2 times x and 2 times 1. So it should have been 2x plus 2 that goes under here. Then I should subtract, and then the 5 minus the 2 gives me 3. So that's my remainder. So let me also change this thing right here and make that into a 3. So that's what I should have had there. Okay. All right. And thank you very much for all of those comments. That really was very helpful. So what I have here now is my quotient form, right? And the other thing that the question asks, if you go back up and look at the question again, you notice that it says, just scrolling back up here, it says, express the result of these divisions in quotient form. We've done that. Identify the restrictions on the variable. Okay. Can somebody help me with that? What value of x could cause a problem here? What value of x could be an issue here? What can x, based on what we have here, not be equal to? X cannot be equal to minus 1, correct? Okay, that's your restriction on the variable. Is everybody clear on what Noah is saying? Why can x not be equal to minus 1? What would cause, why should minus 1 cause a problem? Noah, not just Noah, I'm just asking everybody in the classroom. What is it that makes minus 1 a problem? Can anybody tell me what that is? What's the issue with minus 1? Anybody? Why did he choose minus 1? Why can x not be equal to minus 1? What would the problem be with minus 1? Come on, folks, help me out. There must be a good reason for that. Nobody can think of a reason why minus 1 would be an issue? Go ahead, please, Janaya. Mm-hmm. Mm-hmm. Yeah, and you're going to be left with what? No, you're going to be left with 0. Look at what Harish just said. It would be 0, and you can't divide by 0. It will be undefined when x is equal to minus 1. And that's why we're saying that the restriction is that x cannot be equal to minus 1 because minus 1 causes this to blow up, is the way I say it. That's not the technical math term. That's just how I say it. Minus 1 causes the function to be undefined, right? If you were to try to draw this, when we get to rational functions later on, you notice that you're going to have what's called an asymptote at that point. So it's whatever number makes your divisor become 0 that we call the restriction, right? That's something you should have or would have done back in grade 11 when you were doing rational expressions. So that's what the restriction is. The restriction is that x cannot be equal to minus 1. Now, and see what Riddy did there. Riddy is showing you that minus 1 plus 1. If you put minus 1 as your x value in that, that's going to give you 0. Okay, so let's go back up to the top of this. It says, write the corresponding division statement. Now, here's what a division statement is. The division statement says, multiply the denominator of x plus 1. I'm going to do that right now. Multiply that by the quotient of x plus 2. then add on that remainder. And when I do that, does anybody know what I should get from that based on what I said on the first? You can go back to the first page if you want to. But what should I get by working all of this out? X plus 1 times x plus 2 plus 3. What should I get from that? You can use a word, all right? What do you expect me to get from that? Or you can use the actual expression I should get. What do you expect to get when I work that out and actually, simplify, put all my like terms together? What should I expect? Okay, let's see. Who is that? That looks like Jeremiah. Jeremiah, go ahead. The dividend. That's exactly what the first page said. And the dividend, I remind you, I'm going to circle the dividend so we're clear on what the dividend is. The dividend was, you go back to the top of the page, was that part right there, the numerator. That's what the dividend is. It's x squared plus 3x plus 5. If I don't get that, I made a mistake, right? And in fact, you just caught me in a mistake a while ago. So I would have been able to see I made a mistake from that. So let's find out if this actually works. So x plus 1 times x plus 2 plus 3. So we know how to FOIL, right? So let's go ahead and FOIL. So that's going to be x squared plus 2x plus x plus 2 plus the 3. And when I simplify that, I'm getting x squared plus 3x plus 5. But let's compare that. What we started off with, x squared plus 3x plus 5. It's exactly what we started off with. So that's your division statement right there. And it actually does, and that's what verifying your answer means. It says, write the corresponding division statement, verify your answer. Verify your answer means, is this result, x squared plus 3x plus 5, is that your dividend? Well, it is. If you go back up and look at your dividend, it's the same dividend. By the way, Janaya, when I did that the second time, even though I made a mistake, did that help you to understand the process? We're going to do some more, but did that help you a little bit to understand the process a little bit better? So I tell you what, let's try another one and see if this helps you out. Okay, so come with me now over to number 3, board number 3. We're going to try another one, right? And we'll see how we do with this one, and then you can tell me how you feel about it after that. And everybody else, you're welcome to bring up anything that you're not sure about. That's what the purpose of this is. Okay, so I'm going to first of all draw my little. So by the way, you should now be on board 3 with me. Please join me on board 3. All right, that's where I need everybody to be. All right. So on board 3, hopefully you're seeing what I'm seeing, top of the page. So we should be all on board 3 at this point, right? Everybody on board 3 with me is where I hope you are. I'm going to try this again. We're now dividing by 2x plus 1. So I'm going to do exactly what I did the last time. I'm going to put the 2x plus 1 on the side. Should I use a different color? Let's see if I could use a different color. Give me a second here, folks. 1 second. Trying to find my color palette thing here. I'll do that some other time. Or hang on. Yeah, I can change it right now. Let's do that. Okay. Okay. So I have 2x plus 1. And then I'm going to put the terms under the bracket for the 2x plus 1. I'm going to put in 4x cubed. But you know what I'm noticing? I don't have an x squared term. I have a 4x cubed term. I don't have an x squared term, but guess what? I actually need one, right? So what I'm going to do is I'm going to invent one, right? That must sound a little weird. I'd have to have every single exponent represented. And because I don't have one, I'm just going to invent one. I'm going to create plus 0 x squared, right? So that's one way to deal with that. Just put a 0 x squared in, all right? I have an x term of plus 9x. I'm okay there. And I have a constant of minus 12, so I'm okay there as well. Okay? All right. So that's an important point for you to recognize. The highest term I had was x cubed. I have to have one of each of the exponents represented in my dividend. So if I don't have an x squared term, I'm just going to invent one. I'm going to call it 0x cubed. 0 times anything, of course, is just 0. So it's fine. It doesn't change the expression. It just makes it look a little different, but it's the same expression. Okay, so let's keep going. I'm going to go ahead now, Janai, not just for Janai. I'm going to take the first term of the dividend, the 4x cubed, put that on the side over here. I'm going to divide that by the first term of the dividend, of the divisor, which is a 2x. Okay, Janaya, is that part okay so far? First term, you see what I did on the side there, Janaya? Put the 4x cubed and divide it by the 2x. So the first term of the dividend divided by the first term of the divisor. Janai, is that good so far? Okay, good. And what would you get, by the way, since you're on there now, Janai? What would you get if you divided 4x cubed by 2x? What would you get? Okay, so let's put that on top here. 2x squared. And what I'm going to do now, not just Janai, but everybody else, I'm going to multiply that 2x squared by both of these terms here. So 2x squared times 2x, which is going to give me 4x cubed. 2x squared times 1, which is plus 2x squared. All right, I think I did it right this time. Thank you very much for pointing that out the last time. So 4x cubed, so 2x squared times 2x squared times 1. And as Jeremiah said the last time, I'm going to subtract now. I'm going to subtract. The first terms always drop out because what you did is you divided by something and then you multiplied by the same thing, you're going to get it back. So the 4x cubed is going to go. But I'm going to say 0x squared and minus, see, that's why I needed a 0x squared there, because I need another term to subtract from it. 0x squared minus 2x squared is, of course, minus 2x squared. I'm going to bring down that 9x, so plus 9x. Just like we did the last time. Exactly what we did the last time. All right? So now I'm going to do the same thing again. I'm going to take the first term of this, which is minus 2x squared. I'll do it on the side over here. I'm going to divide that by the 2x. Okay, I see a hand going up. Riddy, go ahead, please, Riddy. Okay, because I'm subtracting. It's 0x squared minus 2. Remember, we always subtract down. So it was 0x squared minus 2x squared. Do you see what I'm saying? Make sense? Okay, good. All right, thanks. Thanks for the question, by the way. So now I'm going to divide minus 2x squared on the side here by 2x. By my math, what I'm getting here is minus x. Okay, so the minus 2 divided by the 2 is minus 1. X squared divided by x is just simply x, so that would be minus x. I'm going to multiply that minus x by both of these terms. So again, I'm always going to get that minus 2x squared back. So minus x times 2x is going to give me the minus 2x squared back. Minus x times positive 1 is minus x. Okay? Now remember, and I'm glad that Riddy just asked that question. I'm subtracting. That's what I'm doing. I'm subtracting. So now I have 9x minus negative x. Right? That's what I'm doing. 9 minus minus 1. So that's actually 10x. And then I'm going to bring down that minus 12. Now, we have to keep going with this division until, here's when you stop. Okay, I see a hand up, by the way. Is that hand just up from before, or is that a new person putting their hand up? I see Riddy and Janai's hand up. Is it? Janai, you still have your hand? What's that? Oh, go ahead, please. Negative x, okay. So after so remember what we did on the side here that we said we were going to divide minus 2x squared by 2x. You saw that part on the side, on the right-hand side of the page. You see that part right there? Right? And we got, we got minus x from that, remember? Okay, so multiply that minus x. Let me put a little red, let me just change that to red here. Multiply this minus x here by both of these terms, right? If you do that, can we agree that you're going to end up with minus 2x squared minus x. Can we agree on that? Okay, and that's where that minus x came from. So minus x times 2x squared is minus 2x squared, and minus x times 1 gives us minus x. Yes, yes, that's correct. Yes. So divide the first term of what you have here by the first term over here. Okay, so now we're over here, we're at 10x minus 12. And on the side of here, I'm going to put the 10x again and divide that by the 2x. Now, I was about to say that we don't stop dividing until the degree of what we have as the remainder is, when that gets lower than the degree of the divisor, then we stop. But we can't stop if they're equal. We can't stop if it's more. So we're going to keep going here. So 10x divided by 2x, of course, is 5. So that's a plus 5. So let's multiply that 5 now by both of these terms. Again, same thing. So 5 times 2x is 10x, and 5 times 1 is positive 5. Okay? So that 5 multiplied by the 2x plus 1. Okay, first term drops out. We're minusing. Just want to keep reminding of that. We are minusing. So when I minus those terms, I should end up with minus 17. So now, when I write this in what we call quotient form, it should look like this. I have 2x squared minus x plus 5. So 2x squared minus x plus 5 minus 17 over the 2x plus 1. That is my quotient form, right? That's my quotient form right there. That's just like a mixed fraction. Quotient, remainder, over divisor. It's just like when we're doing mixed fractions and turning them back into improper fractions, or mixed fractions turn them into, what am I just saying? Let me get it right, get it right way, Sorry, then we take an improper fraction, make it into a mixed fraction. It's the same principle. Now, here's my, okay, so we've done a couple of things. We've done the first part, which is to find the quotient form. What about the restriction? We talked about restriction the last time. What can x not be equal to? What value of x would cause us to have a problem, right? What value of x would cause the denominator to become 0? And Noah says, out of the gate again, real early, it cannot be equal to minus a half. There's our restriction. If I put minus a half in for x, I'm going to get a denominator of 0, and that's going to blow up the equation. Again, my term. That's not a technical math term. You probably don't want to repeat that elsewhere, right? But that's what the restriction is. X is not equal to minus a half. Is everybody clear on how we get the restriction, by the way? Does that make sense, how we got the restriction? Everybody okay with that? I just want to check. Okay, Jeremiah says yes. How about everybody else? Right? Do you understand how we get that restriction? Is there anybody who Joel says yes? Okay, anybody else who is not sure how we get the restriction? Okay, thank you, Emily. Thank you, Reddy. Very quickly, I'm going to check this now against what I started off with. So I'm going to take the 2x. This is my, how I verify it. The 2x plus 1. I'm going to multiply that by the 2x squared minus x plus 5. Then I'm going to minus the 17 from that. And I should, could you please explain that part again, Rachel says. Okay, Rachel, what part are we talking about? This the thing that I'm doing right now? You mean the division statement? Is that what you're asking about, Rachel? Yeah, okay. So go back to the first page with me for a minute then. So go back to page 1. All right, just go everybody back to page 1 for a minute. On page 1, right, look at where it says division statement. Division statement says quotient times divisor plus remainder equals dividend. So remember, the quotient is this thing that is the whole number. Right? I don't think you can see where I'm pointing to. I may go back to the smartboard because I needed to see where I'm pointing to things as I'm going along. The quotient is the 4 in this case. When I multiply 4 times the 3 and add on 2, I give back the 14. That's exactly what I'm doing here. The quotient is the 4. The 3 is the divisor, plus the remainder of 2. That gives me back the 14 dividend. You see what we did over here, Rachel, on the first page? If you're on the first page with me, you see how we got that 14? The 14 is the dividend, remember? Okay, so I'm doing the same thing back on page 3 now. So I'm doing the same thing on page 3. I'm taking the quotient, which is the 2x squared minus x plus 5, and I'm multiplying it by the divisor, which is a 2x plus 1. And I'm and in this case, I'm minusing something because it was a negative remainder. And I'm saying after the end of that, I should get back my original dividend of 4x cubed plus 9x minus 12. I should, right? If we did this right, it should work out. So I had a question I was going to ask you to do on your own, but let's just, because we're limited time we have, let's just do this one together. So 2x times, you know how to find. 2x times 2x is 4x cubed. 2x times minus x is minus 2x squared. 2x times 5 is plus 10x. I see I'm rushing, and that is never a good thing. Okay, let me just erase that quickly. So that's plus 10x. And then let's just see now. So I think I got that right. 4x cubed minus 2x squared plus 10x. And I'm going to multiply everything by 1 now. So plus 2x squared minus x plus 5 minus 17. Okay, so I'm just multiplying everything out now. So 2x squared minus, okay, so the 4x cubed is still there. And then the minus 2x squared, that's going to cancel out with that plus 2x squared. The 10x and the minus x gives us plus 9x. And the 5 minus 17 is minus 12. Let's compare that to what we started off with. 4x cubed plus 9x minus 12. 4x cubed plus 9x minus 12. So now we know that what we did is right. And that's all I'm saying. That's the check. If we made a mistake like I made when I was doing this the first time, then you would have had a problem, right? That would not have given you the dividend in the first place.